Hello, my name is Tianai Gu, student ID 256-62850. This is the code demonstrator for CS7 IS2, Artificial Intelligence Assignment 1. My project is a highly modularized consisting of environment generation, search solver, MDP solver, and a data visualization pipeline. I will now demonstrate its functionality. First, let's look at the man.py. As requirement, the main size and the parameter are not hard-coded. Here, sorry, my computer a little bit hung. You can find here that I highlighted. I realized 20 by 20 maze, and it is not hard-coded. Okay, let's run it. Here's the animation for the BFS. You can see the expand uniformly like a water wave, and this is the yeah, I just closed it, and there is a static image. This is the final optical path. Yeah, I closed the animation because of the time. Yeah, we can it could be running finished. Yeah, and next is the DFS. You can clearly see the go deep first behavior, which often results in a suboptimal optical path. Yeah, okay. Yeah, and this is the path of the and node expanded of the DFS search result. Okay, now we're going to the A star search with the Manhattan distance. Notice how the heuristic function strongly guided the search toward the goal, expanding significantly fewer nodes compared with the DFS and BFS. Yeah, this is the result. And now here is running the A star search expansion with the Euclidean distance. Also, yeah, the expansion was fewer than the BFS. Yeah, and this is the final pass of the A star with the Euclidean distance. Okay, now the demonstrator is going to the MDP. Moving on to the structure stack algorithm. The console shoe value iteration running here is the generated heat map and the optimal global policy for the maze. Yeah, the iteration is finished, and it will generate this image, and the arrows indicate the best action for every single state. And now, following that, the policy iteration also now is running, and it will successfully converges and output the policy. Yeah, this takes time. Yeah, now you can see the animation of the policy iteration of the MDP. And the algorithm dynamically handles the sleep probabilities, which are set to the 2.0, the noise 2.0. And now you can see the arrow, which is the best action for every state. Okay, well, going to the next file. When it comes to the algorithm, search algorithm, the file search solver.py is the Python code I realized. And yeah, briefly regarding the implementation detail, in this file, I implement a unified base search class. Yeah, this is the base search class, and the BFS, the frame of the graph algorithm basically is similar. So the BFS DFS just inherent the base search and just modify the pop measure of the frontier. It will be realized. Now about A star. For the A star, I utilized the Python's hit QP PQ. Yeah, this one. To maintain the front sort nodes by their F score. Yeah, and you can also find the two heuristic function. Yeah, here is the text code. Yeah, now we're going to the MDP solver.py. In this file, the Bellman equations are implemented. For instance, in policy iteration, the policy evaluation continue to update the value until the max change delta is strictly less than the curvature threshold, theta. Yeah. And in PI, policy iterator, there is two main measure. One is policy evaluation, another is policy improvement. I also introduced in the report. And yeah, this is the value iteration. Yeah. And of the run of the value iteration, we'll do the policy extract. Yeah. Okay, now we're going to the benchmark image.py. To conduct a rigorous analysis, I write a automatic benchmark script in bench in this file. I take the main size from 10 to 13 over 10 independently trails. Yeah, this is basically this file, what it's doing. And in MDP parameter experiment imager.py, I performed application studies on gamma, noise, and leading reward. And these two files basically will save the experiments data and imager to the local here. Yeah, and you will see the this CSV file is the experiment data, raw data, and these two folder is the imager when the code is running the experiment. Yeah, and in the end, I will introduce this file, this IP1B file. This file basically used to analyze the data. I write the Python code for the data analysis, and also this picture will be saved in this folder.